Okay, our last lecture for Chapter 6 is about electronegativity. It's our fifth of our final trends. As we look at electronegativity, it sounds kind of similar to our last trend, which was electron affinity. But there are a few differences, where electron affinity was actually the energy change that occurs. We're measuring how much energy change was given off or was absorbed to attract an electron or acquire an electron. Electronegativity is a relative measure of an atom's ability to attract an electron. So instead of being an exact numerical amount, this is how much kilojoules per mole has been gained, this is how many kilojoules has been lost. Instead, what we're looking at is how much ability compared to other atoms do we have. And so we go on a 4-point scale from 0 to 4, with 0 being the least electronegative, meaning it does not want to attract an electron, and 4 being the highest amount of electronegativity, the greatest ability to attract an electron. Well, jumping right into our trends right away, we want to see how does electronegativity change across the table, and then we'll look at why it changes those ways. And basically, as we look at those trends, we see, first of all, that the trend is going to look pretty familiar. As we go across the periodic table, as we go across a row, the electronegativity increases. Ionization energy increased going to the right, electron affinity increased going to the right. So does electronegativity, which should make sense because electronegativity is pretty closely related to electron affinity. And going up a group, electronegativity also increases. And again, the reasons that it's changing this way are exactly the same as they were for both ionization energy and for electron affinity. As you go across the table, your atoms are getting smaller. As they get smaller, the electron that's being attracted is closer to the nucleus, so it's feeling more positive pull from the nucleus. The more positive pull, the easier it is to pull it in. The more pull it's feeling, the more attraction there is. Okay? Going down a group, if we talk about going from top to bottom, the same thing is still the same. As you get bigger, the electron is further from the nucleus, so it's not feeling as much positive pull. The less positive pull it's feeling, the less attraction there is. And obviously also the further to the right you get, not only are you getting smaller, but you're getting closer to that full outer shell. And the closer to a full outer shell you are, the more the electron is wanted to be gained by the atom. So we can add that in as well. Here are two tables that are just showing the electronegativity trend in a couple of different ways. The first one's using colors. We can see on the left-hand side of our screen that we have dark blue colors. That means we have a low electronegativity. We know that the alkali metals would like to lose an electron to get their full outer shell. So they don't have a big attraction for an electron. The same with the alkaline earth metals. As you go across, the electronegativity increases a little bit. There's a little bit more attraction for electron. And as we get over to the end before the noble gases, particularly the halogens, that's where we're going to see our biggest electronegativities. In fact, we see the highest electronegativity up here in the right hand, upper hand corner. This table is just showing us three-dimensionally how that changes. You can see on the left side it's increasing all the way across to the right side. Notice that the electronegativity values are also on here. They're very, very low for our alkali metals and our bottom alkaline earth metals. And as we're getting over here to the right-hand side, our halogens are much higher. It's a nice steep slope here where we have our most electronegative elements on top. Now the next thing to take a quick look at is just to focus for a minute on those most electronegative elements. There are 4 elements that are much more electronegative than any other element. And that's going to play a role in future chapters when we start talking about elements and how they bond together and the types of bonds that they will form. And a high electronegativity, again, means it's the greatest attraction for an electron. And those 4 listed on this table are actually in color: nitrogen, oxygen, fluorine, and chlorine. These by far are the 4 most electronegative. And fluorine is the king of the hill, or top dog, when it comes to electronegativity. It has the absolute greatest electronegativity of all our elements. the greatest attraction for an electron. But the other three are not real far behind. Oxygen is second, then nitrogen and chlorine are really close together. So keep in track of mind of where those electronegative elements are. So to wrap up, we're just looking again at what those trends are. Going across the table, electronegativity increases. Going up, electronegativity increases. The smaller your atom is, the more attraction there is for an electron because the closer to the nucleus it is.